Hello. In this video, we're going to learn about polynomial long division. Now, before we do, let's review some basics of just regular division. In particular, we have 24 divided by 3. Now, a little bit of mental math would probably tell you that the answer here is 8. But what if we had a bigger number? What if it was, say, 84 divided by 3? How would we figure out the answer here? Well, I mean, you could count by threes. I'm sure that would work. But we could also set up the 84 and the 3. 3 goes into 8 two times. 2 times 3 is 6. We subtract the 6 from the 8 to get 2, and then we bring down the 4. Again, it's divide, multiply, subtract, bring down. And then we just repeat a second time. So 3 goes into 24 8 times. 3 times 8 is 24, and we get remainder 0. Okay, well, that wasn't too bad, but what if the number's really big? Like, let's say we have 7 divided into 2,894. Again, we'll follow the same steps, and go ahead and pause the video, see if you can remember your long division. All right, 7 goes into 28 4 times. 7 times 4 is 28. 7 goes into 9 one time. 7 times 1 is 7. That gives us 2. 7 goes into 24 3 times. Oh, but this is going to give us 3. And if you notice, there's nothing left over here to bring down. So because we're out of numbers, well, this final 3 is going to be our remainder. So we can write remainder 3. Again, you've probably done this before. You might remember that sometimes when you do long division, it doesn't go in evenly. But what we want to do is write this sort of like an equation, because putting the R3 over on the side is just, it's not very imprecise. How would you say, it's like we had 2,894 and we were going to divide it by 7. So I guess what, that equals 413 with a remainder of 3? I mean, like, it just looks a little tacky. It's not the nicest way to write the math in an equation format. And so what we'll do instead is write the 2,894, because that's the number we were starting with. And we got 413 groups of 7. So we'll write it as 413 times 7. And then we had 3 left over. So we'll put plus 3. And this right here is the equation that relates to this long division. If you were to break down the big number, you get 413 groups of 7 with 3 left over, so you can write that as 413 times 7 and plus 3. Now, if you don't believe me, go ahead and take 413, multiply it by 7. Let's see, you'll get 21, 9, and then 28. Then add the 3. And of course, we'll get 2,894. All right, well, what does this have to do with polynomials? We could ask the question, how many times does x plus 3 go into x cubed plus 2x squared plus x minus 4, and what is the remainder? Now, it's a little bit strange because you might say to yourself, well, what do you mean go in? Like long division with polynomials? What does it mean to have a remainder from a polynomial? But let's go ahead and follow the same steps, okay? The same idea we had with the long division for regular numbers. We're going to take the same concept and apply it to polynomials. Now, what we're going to do, though, is, of course, our synthetic division. So the x plus 3 here, we can write that as x equals negative 3. And this becomes 1, 2, 1, negative 4. Now we work on our regular synthetic, so this becomes 1. 1 times negative 3 is negative 3. Gives us negative 1, 3, 4, negative 12, negative 16. Now, normally when we get a negative 16, we would say, oh, I guess it's not a factor, it doesn't work out. We'd kind of cross it off and try again. But in this case, because we're not actually trying to factor this polynomial, we're simply wondering how many times x plus 3 goes in, well, we can just write down information from the synthetic. This is actually helpful. This is actually good news. Let me show you. We know that x plus 3 was our factor, although it wasn't actually a factor. X squared minus x plus 4 was our reduced polynomial, and we have minus 16 left over. In other words, x plus 3 went into the bigger polynomial, x squared minus x plus 4 times, with a remainder of negative 16. So this is our remainder. And when you're asked how many times something goes in, that's called the quotient. So you were looking for the quotient, and indeed, the quotient is this piece right here, x squared minus x plus 4. All right, I know that's a little bit weird, but let's go ahead and let's check it. Let's check our answer. If this was the correct long division, it should work out. If we take x plus 3, and we multiply x squared minus x plus 4, and then subtract off 16, we should get the polynomial we started with. All right, so let's go ahead and multiply in the x cubed minus x squared plus 4x. Then we'll multiply in the 3, so plus 3x squared minus 3x plus 12 with our minus 16. So that's going to clean up to give us here x cubed plus 2x squared, and then plus x, and minus 4, which, if we take a look up here, is definitely the polynomial that we started with. So this is correct. Now, just additionally, if you thought that was a little weird that we could use synthetic division to do long division on polynomials, we could do this with actual long division. So we could set it up like this: x plus 3, x cubed, 2x squared, plus x minus 4. All right, how many times does x go into x cubed? Well, if you think about it, if you have x cubed and you're dividing it by x, it goes in x squared times, kind of using like exponent rules. So this will be x squared. X times x squared is x cubed. But then we also have to multiply back with the 3. So we put plus 3x squared. Then we subtract. Remember this step from long division. So these are going to cancel out. And this is going to subtract to negative x squared. And then we bring down. Okay, how many times does x go into negative x squared? Well, if you have negative x squared and you're trying to put x into it, you're going to get negative x times. So put negative x up here. Multiply back. Negative x times x is negative x squared. Negative x times 3 is negative 3x. Remember, we subtract. So those go away, and this becomes 4x. Finally, we bring down. One more time, if you have 4x, how many times does x go into it? The answer is 4 times. So plus 4. 4 times x is 4x. 4 times 3 is 12. We subtract. And we get negative 16, which is our remainder. And up here we have our quotient. Now, if you want to do long division on polynomials like this, you are more than welcome. But I find the synthetic to be a little quicker. I know it's a little bit slick. It feels a little bit like cheating, but as long as you take the factor x plus 3 and you grab the value x equals negative 3, everything will work out great for your synthetic, and you'll get the same answer as the long division, just a lot quicker. All right, here's another question where we have to do division or polynomial long division. Go ahead and pause the video and give it a try. You're looking to find the final answer, so the quotient and the remainder. All right, hopefully you gave it a try. I'm going to set it up in synthetic because I like doing synthetic. Don't forget though that there's a 0x, so we have to put that in the synthetic. And here we get x equals 3. So bring down the 2. 3 times 2 is 6. Add down to get 2. 3 times 2 is 6. Add down to get 6. 3 times 6 is 18. Add down to get 25. So here you have 2x squared plus 2x plus 6. This is the quotient. And here you have 25. This is the remainder. Now it's nice to write it in a nice form. Often we like to write it as the polynomial equals the quotient times the divisor plus the remainder. This is my preferred form. So the polynomial itself was 2x cubed minus 4x squared plus 7. And so we could write it as 2x squared plus 2x plus 6, which is our quotient. We were dividing it by x minus 3, that's the divisor. And then we had a remainder of 25. All right, here's another one for you to try, a little bit bigger. We have a degree 4 polynomial. Go ahead and do the division. Find the quotient and the remainder. All right, hopefully you gave it a try. Again, you're welcome to do actual long division, but synthetic is a lot faster, so it's what I would recommend. 1 comes down, 4, negative 3, negative 12, 5, 20, negative 15, negative 60. We got a remainder of 0. That's interesting. So again, if we write it in our formula, if we have the polynomial, which is 4x, or x to the 4 minus 7x cubed plus 17x squared minus 35x plus 60 equals the quotient. This would be negative 15, 5x squared, or 5x, 3x squared, and this will be x cubed. So we have x cubed minus 3x squared plus 5x minus 15 times x minus 4 plus 0. And in some ways, we don't even really need to write the plus 0. So what this means, which we're kind of used to from the previous lessons where we learned synthetic division, is because x minus 4 had a remainder of 0, that means that x minus 4 is a factor. We can see that this remainder of 0 can kind of be ignored, and we actually factored our polynomial. Pretty cool. So sometimes when you're doing polynomial long division, it does go in evenly, and that's when you have no remainder. That's a factor. Thinking back to our very first example, 24 divided by 8 is going to be 3. And since there's no remainder, that means 3 is a factor. Well, both 3 and 8, I should say. But yeah, 8 is a factor of 24. So in this case, x minus 4 is a factor of the larger polynomial. All right, this one's a little tricky. I'm going to give you the remainder, and I'm going to give you the quotient, and I'm going to give you the divisor, but I'm not going to give you the dividend. The dividend is the big polynomial you start with, the p. So if you were given just the remainder and the quotient and the divisor, could you work backwards to find the dividend? Again, pause the video and give it a try. All right, I think the easiest way to approach this would be to write out the formula. Polynomial is quotient times divisor plus remainder. So if we plug in what we're given, we have the quotient, the divisor, and the remainder. And then we can simply multiply out. So this would be 2x cubed plus 8x squared 7x squared plus 28x plus 6x plus 24 plus 6. So we'll have 2x cubed, 15x squared, 34x plus 30. So that will be our polynomial. And if you were wanting to check your answer, what you could do is take this polynomial with synthetic, 2, 15, 34, and 30. Grab our -4. And if you rock and roll in the synthetic, you should, let's see here. Ah, yes. We have a remainder of 6, and we have our quotient showing up right here. So this is definitely good to go. All right, here's another one that's a little bit of a puzzle. You're given the polynomial, you're given the quotient, you're asked to determine the divisor and the remainder. Go ahead and pause the video and give it a try. All right, well, if we try to use this formula, I don't think we're going to get there because we're missing 2 portions. We're missing both the divisor and the remainder. Now, there is another formula for this that you could use, but instead, I want to just set this up in synthetic and see what I get. So we have 10, -23, -27, 26. And then I know down here I would have 10, 7, and -6. Now, what we can do is a little bit of kind of trial and error, working backwards. If you think about it, we don't know what the divisor is here, but this number times 10 will end up with some number over here. And when that's added to -23, we get 7. So what number has to go there? I think it has to be a 30, because -23 plus 30 will be 7. Well, if that's 30, then this has to be 3, because 3 times 10 will be 30. Okay, well, let's see. 3 times 7 would be 21. 27 as a negative plus 21. Yeah, that works out to -6. Okay. So then 3 times -6, that will be -18. And that gives us a remainder of 8. So the remainder is 8. And the divisor is x minus 3. Make sure you flip that sign. So a little bit of working backwards there. Bit of an interesting problem. All right, let's go ahead and take some notes on these concepts here. So here we were doing polynomial long division. And probably the most important thing was the 4 new words that we learned. So if we have our formula P of x equals Q of x times D of x plus R. Well, I mean, R, that's an easy word, that's remainder. We probably knew that word already. Q is the quotient. That's how many times it goes in. D is the divisor, the thing you're dividing by. And this over here is called the dividend. You might not have heard that word before. Dividend, it's kind of the original number or the original polynomial before you do any dividing. Now, just so you know, there is another formula for this, another way of writing it. You could write it as P of x divided by Q of x. Or sorry, P of x divided by D of x, which will equal Q of x plus R over D of x. Basically, to get this other version, I've simply divided each term by D of x. And this is sort of the fractional form of the same equation. All right, for an example here, I'll give you P of x. Do 2x cubed minus 3x squared plus 4x plus 9. We'll set d of x as x plus 1/2, give you a fraction to work with. And go ahead and determine the quotient and the remainder. Again, for sections 3 and 4, you can choose an example and write down any things to remember. Hopefully you enjoyed that video, and as always, thanks for watching.